Hello everyone, and welcome to my 6th tutorial on how to create full-stack web applications. In this tutorial, I'm going to be integrating persistence into our application, and in order to do that, we're going to have to include a number of different dependencies and also configure a number of different components in our application. Now, I'm also going to be basically implementing a couple functions of a DAO object or data access object to illustrate that we have persistence working properly. So in order to get started, I'm going to go to the MVN repository site and search for H2, which will find for us the H2 database engine library. Now, H2 database is a SQL database, and it will be the database we'll use because it has some pretty good features, such as you can run in an in-memory mode, so it makes testing and prototyping easier. So I'm going to add this to our POM file here. And it's also very fast in its in-memory mode, so that's another advantage to using it. Now, the other library we'll need to include, we're going to have a JPA implementation on our class path. So we're going to search for Hibernate, and you'll want the Hibernate JPA support link, and then the 4.3.5 final version. So go ahead and copy that and place that in your POM file. And we're also going to be using a data source that allows for database connection pooling, because establishing connections with the database can be an expensive operation, so this will help increase performance. So you'll want to search DBCP2, one word, and click on the Apache Commons DBCP link. So this is the Apache Commons database connection pool library, and this has an implementation of the JDBC data source that allows for connection pooling. So you want to paste that into your POM file. And finally, you'll want to include the Spring ORM module, which basically includes a number of different Entitymanager factories that make configuring your connection to your JPA implementation much easier. And so I'm going to include the Spring ORM module. And so that configures our dependencies. Now, we also need to annotate the class that we're going to be illustrating persistence with. So we're going to be showing how persistence works with a particular entity. We're going to be storing and retrieving an account object. So therefore, we're going to have to annotate our account object or our account entity with JPA annotations so that our persistence provider can properly persist our entity. So you'll want to go ahead and specify entity. And also for the ID field, we're going to specify ID here, and we're going to specify a generated value. So this is the minimum annotations you need to have your entity persistible to the database. And so this is all the annotations we'll be using in this tutorial as far as JPA is concerned. Now, the next thing we need to do is have a DAO or data access object to retrieve this object. And so basically, we're going to create a directory to store our DAO objects. I'm going to call this directory repositories, and inside there, I'm going to create an interface that will define our account repo repository, or our account DAO object. And I'm going to have it basically implement the same methods as in our account service. Now, basically, our account service will proxy calls to find account to the account repo implementation of the account repo. And basically, account service will not be working with any implementation concerns as far as the database is concerned, and will instead just implement what you might call business logic or domain logic, and basically orchestrate the different components in our application to work together to fulfill different use cases. So basically, I'm just going to copy over these methods and place them in our account repo here. And I'm going to create an implementation of our account repo, which will be our JPA implementation. So I'm going to create a package here. I'm going to call it JPA. And I'm going to call this class JPA account repo. Now I'm going to implement the account repo class. And I'm going to add default implementations of these methods. Now, one thing we need to do is we need to add an annotation to our JPA account repo, since it's going to be an injectable Spring bean, and basically it's going to be a singleton bean, or a single instance in memory that can be injectable. We're going to want to add an annotation here, and we're going to specify repository, and this will create will allow us to inject basically what you call a Spring singleton bean. And also the repository annotate. Now you can use component annotation to do the same thing, but repository has some other benefits, such as exception translation. And what exception translation is basically any kinds of exceptions that we throw. If we throw JPA exceptions, or if we throw JDBC exceptions, all these exceptions from differing persistence frameworks will be translated to a common set of exceptions that can be called in our service layer. So that's an advantage to using the repository annotation, and our JPA account repo will be used by our service layer because our account service will be proxying methods to this object here. So now that we have the repository annotation, our account can be component scanned, but before I continue, I'm going to create a test class which will test the injection of this object with, and then once we can see that we're injecting this object properly using our test, I'm going to then go on to the next part. So first I'm going to create a package here, and I'm going to use the same package name as this class here. So I'm going to create this and call it tutorial.core.repositories. So we're just testing the interface right now, and you could basically plug in different implementations and see that they fulfill the same contract that the interface defines. So I'm going to call this account repo test. Now, this is going to be a test that's going to use the run with annotation of JUnit to provide a custom class test runner. And this will allow us to plug in a Spring test runner, which will allow us to inject Spring beans into our test, and also configure those beans using a configuration file. So I'm going to specify the run with annotation and use the Spring JUnit for class runner. And I'm also going to specify the context configuration, which will allow us to specify a Spring bean configuration file to configure the beans for our account repo test. So I'm going to specify that this is on the class path in a directory called Spring, and I'm going to call this file businessconfig.xml. And I'm also going to add this so I'm going to add this to our class path by creating a directory under the main directory in our project folder, and basically Maven will look for the resources directory under the main directory for class path resources that need to be included in the distribution. So I'm going to create the directory resources under main, and you can see that the resources directory is under main, and I can go ahead and now create the directory structure for the files we want to include on the class path. So I'm going to create the directory Spring, and inside there I'm going to create the file businessconfig.xml. Now we need a basic beans configuration tag just for this to be recognized as a Spring Bean configuration file. So you want to go to the MVC dispatcher servlet and copy all this configuration to our business config file, and just erase everything we don't need. So we don't need any of this. And if I go back to our account repo test, and I create a test method here just to verify everything's working. It should say that the application context is being loaded. So let's try this. Okay, so if I go ahead and run this now. Okay, so it says loading XML bean definitions from class path resource of Spring business-config.xml. So it is loading properly. Now we would like to check that the file that our repository can be auto-wired correctly. So let's see. I'm going to go ahead and add the auto-wired annotation, and I'm going to create the account repo class. Now, basically, we're going to go ahead and we're going to just run this just to show that that it fills because it can't find the account repo. So it's looking for the account repo, and no such bean definition found. So we're going to have to component scan for our account repo. So I'm going to add components again, and I'm going to scan the tutorial.core.repositories.the directory for the implementations. And if I run this now, it should say that it's auto-wiring successfully. So now our component is being scanned correctly. However, now what we'd like to do is actually implement implement our data source to connect to a database. Now basically, to connect to a database, you need an entity manager factory bean, and Spring provides a number of different kinds of entity manager factories, but we're going to be using the local container entity manager factory bean, which basically is what you would use in a production environment and allows for the most configuration as far as configuring your the connection. So I'm going to the first step to creating our local container entity manager factory bean will be the creation of a data source that has the correct properties to connect to the database. So I'm going to create a data source bean, or a now all Spring beans are singleton beans, which means that there's a single instance we're creating in memory, and we specify a bean name using the ID field. So I'm going to specify data source as the ID for this bean. So this will be a single instance in memory that we're creating, and we're going to use the class definition of basic data source. So that's going to be in the org.apache.commons.dbcp2 package. And this is a data source that will support connection pooling. Now, in order to set properties of our instance, we specify the properties the properties as defined in the class definition. And so I'm going to specify a property here of username and a value. I'm going to specify SA. Now you can replace this with properties defined in a configuration in a properties file later on, but for now I'm just going to be specifying them inline. And I'm going to specify a password of SA for superadmin. And I'm going to specify a URL now. Now the value you'd like to specify for your URL is implementation specific based on the kind of database you're using. So I'm going to be using the H2 database engine. So if you go to the H2 database engine site and you click on cheat sheet, you can see a number of different URLs you can use to configure your database. We're going to be configuring an in-memory database with potentially more than one connection. So we're going to want to use this URL, this particular one, for an in-memory database. So you should copy that link and place it in the value over in this property. And finally, we need to configure a driver class name, which is the basically the full package name and class name, the full name for the driver based on the inclusion of the H2 database engine. So I'm going to include the org.h2 dot driver class. So that includes the driver from the H2 database engine library. Now that our data source is configured, first, whenever you configure Bean, it's a good idea to run your application and see that all the properties are being mapped correctly. And it would complain saying, if I put in spurious data here in our property, you can see that it will crash. So basically, our properties are being matched correctly. And so now what we would like to do is add a local container entity manager factory bean. So I'm going to specify entity manager factory, and I'm going to specify a class of local container entity manager factory bean, and that will be in the org.springframework.orm.jpa package. Now this is, as I said, the most flexible entity manager factory bean, and the one you should generally use. And I'm also going to specify a property for a data source. Now, in order to reference existing bean in your configuration, you can use the ref tag. So I'm going to be referencing to set the data source property of our local container entity manager factory bean. I'm going to be referencing the data source bean over here. So I'm going to specify data source here, and the next thing we'll need to configure is the JPA vendor adapter. Now, this I'm going to use an inline definition, which will set the value using whatever is contained inside this property tag. So I'm going to use the inline. I'm going to create an inline bean definition here, and I'm going to specify the class of the Hibernate vendor adapter. And this is basically letting Spring know that we are using Hibernate as our JPA implementation. So you'll want to search for org.hibernate vendor adapter. So we're going to use the Hibernate JPA vendor adapter here. And you can see it's in the org.springframework.orm.jpa.vendor package. So I can just actually end this tag with a slash, and I don't need to specify the bean tag down here. So that's all we need to configure our JPA vendor adapter. The next thing we need to do is configure some basic properties of our entity manager factory. Now these can be JPA properties as defined by the JPA specification, but they can also be properties as defined by the implementation, the JPA implementation. So basically Hibernate can define basic properties as far as these are concerned, and these are called JPA properties. And you can specify them using a Java map, and one way to specify a Java map in Spring is to use the map tag. So I'm going to specify a number of key value pairs here, and the first one I'm going to specify is a Hibernate property called HBM2DDL, which is a way of specifying how you would like your how you would like Hibernate to generate your database. So basically, you can specify a create drop. You can specify create drop for this field, and this will basically create the schema on startup and drop the schema on finishing the execution of program. So you want to copy over this property to your file here, and I'm going to specify a value of create drop. And for the next one, I'm going to specify the show SQL property of Hibernate, which will allow us to basically show the different SQL statements Hibernate is executing, which will be useful for testing purposes. So specify a value of true for that. And the final thing we'll need to add for our entity manager factory bean is a property for the packages to scan field. And this is basically specifying the directory where our entities are located. So I'm going to specify the tutorial.core.models.entities package. So now our account class should be properly scanned based on that. Now, If I go ahead and run this, we should be able to see if all our properties are being mapped correctly. And you can see that they are, and Hibernate is dropping our account and then creating an account table, and then on finishing the execution of the program, dropping the table again. So everything is working properly. And the next thing we'll need to do is add allow for in a transaction scoped entity manager. So basically what we want to do is we want to inject an entity manager into our service class, into our repositories, but it's important that the entity manager and its persistence context is transaction scoped. So what that means is that entities outside of the transaction demarcation, entities that we attach during a transaction demarcation become detached after the transaction has completed. So in order to add this, we're going to use the tx annotation driven command, but in order to do that, you're going to want to include the tx namespace. So I'm going to go to the Spring documentation and search tx:, and you should be able to find a part of a configuration file that includes this namespace. So go ahead and copy this namespace into your configuration file, and then specify a schema location. Okay, so now we have tx on our in our configuration file configured, and I should be able to write tx, and you can see different kinds of code completion. Now, basically, we're going to want to specify a tx annotation driven command, which accepts different properties, and one of the properties accepts is a transaction manager. Now, by default, a transaction manager is auto wired based on the name. So, for example, you'll have tx annotation driven will use the bean with the name or the ID of transaction manager camel cased. So you can specify directly the transaction manager by specifying name here, but we're going to use the we're going to have it auto wire that field. So basically, tx annotation driven will auto wire the bean we define in this configuration file. And tx annotation driven, the purpose of it is to allow for our Spring to scan for transaction demarcations. So I'm going to specify a transaction manager here, and this is basically a basically Spring defines a platform transaction manager. And let me see here if I can find the interface definition for it. Basically, it's a strategy for implementing a transaction. It's an interface for implementing a transaction strategy. So it's an abstraction that allows you to implement transaction strategies for JPA and also for JDBC or JTA. And basically, there's a particular implementation called a JPA transaction manager, and that's the one we're going to be using since we're using JPA. So I'm going to create that bean. I'm going to call it transaction manager, and this is the name that our annotation driven tag is going to look for. So it's important that you use this name, or if you don't use that name, to specify that field using the transaction manager field of our annotation driven command. So I'm going to specify a class of the JPA transaction manager, and you can see it's in the org.springframework.orm.jpa package, and I'll end that tag there. And that's all you need to set up transaction management in your application. Now, in order to inject, actually test create the methods for our account repo, I'm going to implement a couple filling tests. But first I'm going to run our program to make sure we don't introduce any new bugs. Okay, so you can see everything's working properly. Now I'm going to create a setup method here. And inside our setup method, I'm also going to add transactional, because we're going to set up we're going to execute some methods on our repo, and it's important that our repo works inside a transaction area demarcated with transactional, so that we can have an entity scoped transaction scope entity manager. So I'm going to also specify, and I'm also going to specify a rollback false, because by default, when you use the Spring JUnit4 class runner and you specify a transactional annotation on a function, by default Spring will roll back your transactions, and we would like our persist functions to be accessible. We'd like any effect of our persist functions to be accessible in the method where we're retrieving the objects we just persisted. So I'm going to specify here public void setup, and I'm going to create a new account here and specify some basic information. And I'm going to assert that our account, well, actually, I'll just persist this to the database and just access it test find. So I'm going to test find there, and so I'm going to, so this is set up more or less as testing create the field. So I could even maybe, well, basically if we can find it, it's probably been created correctly. So I'm going to specify here, I'm going to save our account now, and I'm going to use the create account method here. I'm going to place an our account. But it is part of our account definition, our create account function that, well, yeah, okay, so that should work for this test. And then for this test, we're going to test that when we find the account that it's not null. So I'm going to go write down assert not null. I'm going to import that from the org.junit package. And I'm going to specify repo.find account, and I'm going to specify the account.getID. Now, so our account needs to be an instance field for this to work. So I'm just going to erase this and create a field here. Now, it is important that our find method also, even though it's not changing the database, it's also important that it functions within a transaction, or else an Entitymanager won't be an injectable. So, or it won't work right. Basically, transactional, our Entymanagers and their persistence context are transaction scoped, meaning that the entities become attached during a transaction. So make sure that even your getter methods are wrapped in transactions. And basically our service layer of our application will be managing the transactional behavior of our DAOs in later tutorials. So this should be a good test, and I'm going to run our application now. And you can see it should fill, okay, so with an assertion error, okay. So basically we're going to implement this logic now in our repository. So go ahead to your JPA repository, and we're going to inject a transaction scoped entity manager. So we're going to specify persistence context, private entity manager, EM. And to find the account, I can simply call em.find with account.class and the specified ID. And for creating the account, I can go ahead and write em.persist data, and then just return that data. So if I run this, it should work, and persistence context manages whether or not this entity manager is transaction scoped or not. So basically, by default, persistence context, you can configure this annotation with additional attributes to change that, but by default, it is transaction scoped. So I'm going to run this. This should work. And you can see it passes. So basically our tutorial, this, I think this concludes our tutorial, but basically we covered a lot of information on how to configure your JPA implementation and how to access a data source, and also how to access data pooling how to use the database connection pooling component of Apache Commons. So we have a pretty good setup for later tutorials. In later tutorials, we can now in a much easier fashion implement the rest of our DAO objects, and by that time we should have a mostly working backend for our application. Anyways, I hope you guys found this tutorial helpful, and if you did, like and subscribe to my channel, and thank you for watching.